So we previously learned in 11.2 that we have a generic form to find any term of a sequence. So sequence terms is what I'm going to write here. And why is it important to know what terms of a sequence, what their values are? Well, if we are given summation, as we learned that our sigma notation is summation, we need to know what we're adding up and what numbers that we are adding up. And the important numbers that we need to have are our first and our last number. So we explored using our sequence of odd numbers. We explored this pairing method when it comes to arithmetic sequences. And we said, when we take our first number and we take our last number and we add them up, what we find is that subsequent pairs add up to the exact same amount every single time. So if I have a summation and I have a notation that is asking me to sum them up, I really only need two values. I only need the first term, a sub 1, and I only need the last term. What we learned with our expression for summation is that we are given that. They will give us the first term and they will tell us how many terms that we are going to. So in this case, I am summing the first 5 terms in this sequence. I'm going from 1 to 5. Maybe in this one, we are looking at 2n minus 1. That is the value expression for this sequence. And I want to add up the first 5 numbers. Do I need all 5 numbers? No, I do not need all 5 numbers. I only need the first number and the last number because I know that everything else in between will add up to the same amount. And I also only need to know how many terms I actually have. So in this case, we have 6 terms, 1, 2, 3, 4, 5, 6. And you can see that we have 1, 2, 3 pairs. So I have my first and my last term, so a sub 1 plus a sub n. I've added those together, and I have 3 of them. What is 3 in relation to what I have? Because we are pairing. Remember that pairing means we're taking 2 things and we're putting it together. We are taking 1/2 of what we started with when we pair it up together. So if I start with 6, I'm taking 1/2 of it, which gives me those 3. Now, for odd numbers, if I start with 7, I'm still taking 1/2 of 7. So I would have 7/2 or 3 and 1/2. So I would have 3 full pairs and 1 left over. So let's add that and see if that really plays out. So we're going to add ourselves an extra little term over here and make it 13. So now I am pairing up, and 5 now pairs up with 9, and I get left with this number right in the middle. Okay, 13 plus 1 is 14, and the number I'm left with is 7. Okay, we just showed that the number that is left over is exactly 1/2 of what our pairs come out to be. So we can generically write a rule for summation and say that anytime I am asked to sum up or to add up a sequence of numbers, it's going to be the first term plus the last term, and I'm going to have half the number of pairs of what I started with in the first place. You will often see this written as however many terms that you have, a sub 1 plus a sub n, all over 2. Remember that when we are dealing with multiplication, if I had that over 1, that this is really the exact same thing. I've just moved the 2 underneath one of the terms for multiplication. You may also see it written as n times a sub 1 plus a sub n over 2 in that way. Exactly the same. Because of the commutative property of multiplication, our 1 and our 2 can go under either one, or it can be combined under all of it. So all 3 of these ways that these are written are the exact same thing. It means exactly the same. When it is written in this first term, it says add the first and the last, and then you have half the number of pairs of what you started with. When it's written in this way, we could say add the first and the last and multiply it times your number of terms and then take half of it overall. When it's written in the third way, we could say take the average. Remember, average is always the addition of numbers divided by how many numbers you're adding. And in this case, we're adding 2 numbers. So we're adding the first number and the last number. That gives us 2 numbers. We're taking their average, and we're multiplying the average times the number of terms that we have. It's all the same, however your brain wants to think about it as it's pairing it. But we now have this new formula that tells us for the sum of any amount of numbers, we have however many terms that we have. We have the first term plus the last term, and we have half of that total amount. Okay, so this is a great formula to be able to use now that we get to use our expressions in our summation term. So we may have to go back and use our expression if they didn't give it to us in the first place so that we could find our sum, because we need to find the first one and we need to know the last one. So for on your homework, we've got 45 through 50, and it says to sum up the first n number of terms in these arithmetic series. So we know we are using both of our arithmetic formulas. For 45, it's telling us that that n is equal to 20. So we are going to be adding up 20 terms. And it gives us 3 plus 8 plus 13 plus 18 plus 23. Okay. So on this one, we know we need the 20th term. We don't quite know how to get to the 20th term, so we're going to have to go back and find that. So the very first step before we can even start summing is we have to find the equation. So what do we have? We have a jump of plus 5 each time so that we know that our value D is plus 5. We know that our first term is 3. So I can say for any value, I'm going to take my first term, I'm going to jump 1 less times, and every single time I jump, I'm going to be 5. So my value for any term is 3 plus 5n minus 5. A sub n is equal to negative 2 plus 5n. So say I went backwards. Remember we talked about that a sub 0. Say I went backwards 5, I would end up with negative 2. So we have that proven there. Okay, so here is my value. Now to sum up all of these, they want me to go to 20 terms. So I know what my first term is. I know my first term here is 3. But what is my last term? So a sub 20 is going to say I start at negative 2 and I go 20 times. 5 times 20 is 100. 100 minus 2 gives me 98. So my last term is 98. So if I was pairing, 3 would be paired all the way down here with the value 98. And that tells me that every single pair all the way through would add up to 101. So I have pairs that add up to 101. A sub 1 plus a sub n gives me 101. And how many pairs of those do I have? Well, I have 20 numbers, and I'm going to have half that for my number of pairs, which means I'm only going to have 10 of them. So my sum is going to be 101 times 10, which means I simply just add a 0. So in this case, we had to go back and we had to actually find our expression first so that we could find that last term in order to plug the last term into our equation. There. Right? So for 45 through 50, that is what you're going to have to do. They are going to give you how many terms you need to find, and they're going to give you the value. So you're going to have to actually write out your expression, use our sequence formula to find the expression before you can find the end term. Then if they ask you to sum something, it says for 45, it asks to find S sub n, which is saying S sub 20, because in part A, they gave you the n value equals 20. So that they want to say, what is the value at that location? Okay, and you're going to plug in that value there. Okay. Okay, so for number 47, let's look at it. They give us the values -10, -5, 0, 5, 10, and on. So if this were our terms, right, for our sequence, they're asking us for n equals 19. So we want the 19th term of this sequence. So how do we find the 19th term of the sequence? Well, first we've got to go back and use our sequence formula. So we know that we can find any term, means from where we start, plus those number of jumps, however many jumps we make, of our common difference. So what do we have here? It looks like we are adding 5 every single time. So our D value is 5. They are asking us for the 19th term. So the 19th term is going to be equal to wherever I start with. I started at -10. I'm going to jump 18 times. And so we know that our 19th term is going to be 18 times 5. We've got 90. 90 minus 10 is going to give us 80. All right. So the 19th term of that series is going to be 80. Then the instructions say find the sum of the first n terms of this series. So now they want us to sum up from 1 to 19 the series that we have been given. Well, the only thing that we really need to know is we don't even need to write out the generic expression. We know that when we add the first term and the last term, that we're going to get that pair. So we've got our first term, our last term is our 19th one. So our first term is -10. Our 19th term is 80. That when we add these up, everything in the middle is going to pair up to be the exact same amount. And the number of pairs that I have is going to be 19 divided by 2. So 80 plus -10 is going to get me 70. So everything in the middle is going to pair up to be 70, and I'm going to have half of 19 of that. So 2 goes into 70 35 times. I'm going to work this out. 35. I don't have a calculator with me. 9 times 3 is 27, 28, 29, 30, 31. Then we have 5 and 3, just for those who still need work on their long. So looks like we've got 665. So if I were to add up all of those values, the sum from 1 to 19 the 19th term is going to give me 665 when I sum that up. Okay. So for 51 through 55, they already give you, instead of asking you to find the term, so 45 through 50 has an extra step because we've actually got to find that end term in the first place to be able to sum it up. For 51 through 55, they give it to you, and they give it to us in our summation notation. So once again, we have to know how to read the instructions that they have given us. For 51, we have I equals 1 to 20 of 3 plus 5i. So this says to sum up 20 numbers. If I were to write out, I would write out 20 different numbers. I'm going to add them all together. And the numbers are related according to the expression 3 plus 5i. Well, we know according to our formula that I only really need the first one and the last one. And then I will have half of those pairs. So the first term, if I plug in 1, I've got 3 plus 5 times 1 gives me 8. My last term, if I plug in 20, I have 3 plus 5 times 20. This is 100. So I have 103 is my last term. 103 plus 8 gives me 110. No, it doesn't. It gives us 111 for that. And that means every pair all the way down is going to give us 111 every single time. So how many pairs do I have? Well, I have 20 terms, and I have half those numbers of pairs, which means I've got 10 pairs. So I'm going to take 111 and multiply it times 10 and get 1,110, and know that when I sum up those first 20 numbers, it's going to give me 1,110. So that is all that we have to do for 51 through 55 is find the first term, find the last term, and then know how many pairs you are actually adding together. Then for 57, we have a word problem. So how do we take what we know and apply it into our word problem? It says domestic bees make their honeycomb by starting with a single hexagonal cell and then forming ring after ring of hexagonal cells around the initial cell as shown. The number of cells in successive rings forms an arithmetic sequence. Okay, so the important thing to notice is that they are calling the initial cell not a ring. Then it shows a ring with 6, and it says this is the first ring. So as we write out our sequence for ring 1, ring 2, ring 3, ring 4, this first initial cell is not included in the sequence. So for the first ring, we have 6. And when we look at the picture, we see for the second ring, we have 12. Well, how are we changing? What are our jumps for the third ring? If you actually drew it all out, you would see that it is 18 in that case. So what we have is that we are adding 6 each time to that. We are also simply multiplying our n value by 6. That is what it's working out like. So for this one, we were able to deduce and say that our a sub n is equal to 6 times n. All I have to do is take my term value and multiply it times 6. If this was a harder one, we could use our generic formula that says that any value is equal to the first value plus however n minus 1 jumps times whatever you're jumping by. And we could say that our second value, so a sub 2 here, which we know to be 12, was our first value of 6, plus I only jumped one time, times this d that I don't know. A sub 2 is really 12, so 12 is 6 plus 1 times d. I'm going to subtract 6 from both sides, and 6 is equal to d. So we're able to go back and actually use our generic formula to be able to find any location in our equation to tell us what our jumps were if we weren't able to figure out those jumps in the very first place, right? So in this case, we know that we're jumping by 6n each time. And then it says, what is the total number of cells? When they say total, that means a sum. We are adding them all together. So automatically, we have some sort of summation. Total number of cells after the 9th ring. So we're starting at 1 ring, and we're going to 9 rings. And we know it goes according to the expression 6n, and they want us to add up all of the hexagonal cells that we have. So we know that we only need the first term, a sub 1, and we need the last term, in this case is a sub 9, and I'm going to have half of 9 of them. A sub 1, we plug in 1 is 6. Our last term, 6 times 9, gives us 54. 54 plus 6 gives us 60. So I've got 60 times 9 halves. 2 goes into 63 times, and I have 270 in the rings, okay? And then it tells you, hint, do not forget to count the initial cell. Because remember, our sequence did not include this initial cell. It only included the rings. So 270 is the amount that add up in all the rings plus our very initial one. So if we were to count all of the honeycomb little cells that we have, we would have 271 of those cells. So the same rules are going to apply for 60 as it is talking about seating. Okay, and I always suggest to write it out first. It says, suppose each seat in rows 1 through 11 cost a certain amount. In example 6. So it's going to ask you to go back and look at example 6. Example 6 says that the first row of a concert hall has 25 seats. So in our A sub 1 here, we've got 25. And it says after the first row, every row has 1 more seat than the row before it. So that means the next one would have 26, the next one would have 27, and so on and so forth until we come to the 32nd row. So we would need to use our generic formula, A sub n equals wherever we start plus however many jumps. How many times are we jumping to get to 32? We're jumping 31 times. And what is our jump each time? Our jump each time is by the number 1. Where did we start? We started at 25. So our generic formula is 25 plus 31. So to find our A sub 32 down here, A sub 32, we know that at the very end, we have 56 seats in that last one down there, okay? So it starts at 25 seats. It goes all the way to 56 seats. So then it says, suppose each seat in row 1 through 11 costs $24, and each seat in row 12 through 22 costs $18, and each seat in row 23 through 32 costs $12. How much money does the concert hall take in for a sold out event? So in this case, we're going to have several different summations. The first one, they want you to sum up from row 1 through row 11. How many seats are from row 1 to row 11? Well, from row 1 to row 11, we know that we are going by the formula. Our first one is 25 plus n minus 1, and we're jumping by 1 each time. So from row 1 to row 11, we need to add A1, add A11, find out the value for A11, add those up, you have 11 seats. So we have half of that with that pair, and that will give you how many seats, total seats, in those rows. Now that we have the total seats, we're going to multiply by the cost of each of those seats. Now, for the second part, they're asking you to sum up rows 12 through 22. Okay, so for rows 12 through 22, we're going to need the value at the 12th. How many seats does the 12th row have? How many seats does the 22nd row have? And we can use our generic formula for the seats for that. We're going to add those up, and we're going to say how many rows do we have total, and divide that by 2, and that gives us our number of pairs. And then that gets multiplied by the cost of those seats. Then we have a third formula. We are wanting to know from 23 to 32. So I'm going to need the value at 23. It's going to be added to the value at 32. Those will all pair up. How many do we have from 23 to 32? 23, 24, 32. You're going to find that there are 10 rows there. So we will have 5 pairs of this value, and they are each going to cost a certain amount. So for 60, we have 3 different summations that we are adding up to find the total number of seats for those rows. If we were to kind of visually look at that, what we basically have is this triangle. And so for the first part, we are adding up the number of seats here and multiplying each of them by a certain cost. Then we're adding up the seats that we have in the second part, and we're multiplying it by a different cost. Then we are adding up the seats that we have in our last part, and we are multiplying those times a third cost. So you can see that the number of seats in each section is separate, and that our summation would give us different values of where we start. We're starting at different rows, and we're adding to the next one.